like this. One end of a light spring of spring constant K and natural length L naught is fixed, and the other end is attached to a block of mass M. Okay, ma? So consider, first of all, this was a spring, ma? Okay, and what was the natural length of the spring? Natural length of the spring was L naught. Natural length means what? There is no elongation, there is no compression. Okay, ma? So if there is no elongation, if there is no compression, there is no centripetal force also, there is no restoring force also, nothing is present. So now what we are doing to this mass, we are attaching a block of mass M lying on a smooth surface. So if the block is rotating in a horizontal circle of radius L, then what is the frequency of revolution? Clear, ma? Now to this same spring, okay, what we are doing, we are attaching a mass of small m, which is present on a smooth horizontal table, and we are rotating this one in a horizontal circle. If I rotate this one in a horizontal circle, then what is the radius of the circle, ma? Radius of the circle created is small l. Okay, small l or capital L, let us write it as capital L. Radius of the circle, let it be capital L. Okay, so original length of the spring is L naught, but when we started rotating, then the radius of the circle created is L. What do you understand? What do you understand from this? Radius of the or length of the spring, is it increasing, or length of the spring, is it decreasing? What is happening? Length of the spring increasing. How can you say? How can you say that length of the spring is increasing? Natural length is L, but when it started to rotate in a circular path, then radius of the circle is L. Natural length was L naught. So what do you understand? Length of the spring, is it increasing, or length of the spring, is it decreasing? N and L naught both are not same number. L is different, L naught is different. So what do you understand? Length of the spring should increase or decrease? Increase. How can you say? How can you say length of the spring increases? What you are saying is correct. Length of the spring definitely increases. Are you able to understand, ma? But how can you say length of the spring is increasing? Okay, ma? Now it is moving in this circular path with an angular velocity of particular omega. Okay. So original length was only L. Are you able to understand, ma? But final length is how much? Final length is L. Original length was L naught. So what is the extension produced? Extension produced is L minus L naught. This is the extension produced, number. The elongation produced in the spring is L minus L naught when the body started rotating. Question is, why spring should elongate? Why it should elongate? Can you say? Why spring should elongate? So, if mass is present, why it should elongate? It is not, spring is not held vertically, no? Spring is present in horizontal direction. Because of this mass, there is no elongation. Because of mass, there will not be any elongation. Why it is elongate? Anybody? Sima, for this body to move in a circular path, centripetal force is required, no? For any body to move in a circular path, what force is required? Centripetal force is required. And here, who will provide the centripetal force? Spring should provide the centripetal force. How spring can provide the centripetal force? And centripetal force will be in which direction? Towards the center, no? And spring can provide centripetal force towards the center only when spring develops the restoring force towards the center. That's it. So restoring force should be in which direction? Restoring force should be towards the center of the circle. And this restoring force is nothing but a centripetal force, because that is the force which is acting towards the center, no? And restoring force will act in this direction in which condition? Only when elongation is in opposite direction. When elongation is in opposite direction, then restoring force will be in another direction, because by Hooke's law already we have studied, no? Restoring force is directly proportional to minus x. What is meant by minus x? If elongation is in one direction, restoring force will be in opposite direction. That's it. So elongation E వైపు ఉంటే restoring force opposite direction లో ఉంటుంది, and that restoring force is responsible for providing centripetal force. So therefore, if I complete this equation, then I can write restoring force is minus k into x number, where k is called as the spring constant or elongation constant. Okay. So therefore, restoring force is nothing but centripetal force. Centripetal force is how much? It is mr omega square is equals to minus k into x. Okay. So mass of this body is m. Now what is the radius in which this body is rotating? Radius is L only, no? In a radius of L, this body is rotating. So radius is L and omega I don't know. Clear number? So minus spring constant is already given as k. And x. X means what? Elongation. What is the elongation? L minus L naught. Elongation produced is L minus L naught. Understood now? Clear? So therefore, just to calculate this omega value, so let us forget this minus here. So omega is equals to how much mass? Square root of k into L minus L naught divided by m into L. So this is the omega value, angular velocity with which this mass should rotate. But what he is asking frequency, no? Again, how can I calculate frequency? So omega is equals to 2 pi into f. Okay. Therefore, what is the frequency? Frequency is equals to omega divided by 2 pi. So therefore, 1 by 2 pi is square root of k into L minus L naught divided by m. So that is the answer. Clear, no? That's it.